What I want to discuss now is Pythagoras property. Okay, so Pythagoras property. We have this triangle here, and let's name it A, B, and C. This triangle ABC having right angle, that is 90 degree at this vertex B, and this is a right angle triangle. So the side opposite to this right angle, that is this side AC, will be called, again listen properly, that the side opposite to the right angle of any right angle triangle will be hypotenuse. In this case, AC is a hypotenuse. Why? Because we have B, the right angle at vertex P, and the opposite side is this AC. And rest two sides, that is in this case AB and BC, will be called legs of this right angled triangle. Okay, now this was about a right angled triangle. These terms are about a right angled triangle. What is a Pythagoras property? Well, let me remove these vertex in order to explain you what is Pythagoras property. But remember that this is hypotenuse and these are two legs of this right angle triangle. If I draw a square on each of these sides, that is on hypotenuse and these two legs, so what I'm doing is I'm drawing a square on this hypotenuse. So since I'm drawing a square on this hypotenuse, therefore each side will be of length what? C. Why? Because C is a hypotenuse, and in this case each side will be equal to C. So this is a square that has been drawn on this hypotenuse, where each side is what? Is actually C, of length C. Similarly, we'll draw here a square on this leg, on this side, of the length B, having length B. Let's do it. So if I have to draw a square, okay, so each side will be of length B. Okay, now I want to draw a square of length A, because this side is of length A. So if we do this, then it will be something like, it's a really very rough diagram, so maybe it's not a very accurate square, but just assume that we have drawn a shorter. Okay, so this is A, this is A, this is A, and this is also length A. A square on the hypotenuse of length C, a square on hypotenuse with sides B of length B, and a square on this side with length A. According to Pythagoras property, the area of a square on this side having length A, so what would be the area of this square that has been made or drawn on this side A? The area of this square will be what? A square, right? A square. Since we know that area of a square is what? Side times side, side multiplied with side. So A times A is A square. And let me write it completely. So A times A is A square. What will be the area of this square? B times B. So B square. And what will be the area of this square? That will be C times C, that is C square. According to Pythagoras property, this is 1, 2 and this 3. If you add 1 plus 2, that is this a square plus b square, this will be equal to 3, that is will be equal to c square. So a square plus b square is equal to c square. This is Pythagoras property of a right angled triangle. It's only applicable to a right angled triangle, because if you have hypotenuse, then hypotenuse can only exist in a right angled triangle. So for any right angled triangle, this Pythagoras property will always hold true. Now we are not going to discuss about proof of the or formal proof of this one, because this particular thing that is the formal proof for Pythagoras property, you will learn when you will move to some higher standards, okay, higher grades. So if you are given that a triangle is a right angle triangle, then this Pythagoras property will always hold true. And next important point is that this hypotenuse is the largest side of a right angle triangle. That is, C will be greater than A, and C will be greater than B. That is, C will be greater than A and B both. Okay, so this is really very important. And why it is important? Let's understand this with a problem. Sides given are 3 cm, 4 cm and 5 cm. It's asking that if you have been given these three lengths of the three sides of a triangle, then will it be a right angle triangle? So as we discussed here, that any right angle triangle will always follow this property. It will have to follow this property. So in this case, if you see 5 cm is the largest side in these cases, you are simply checking whether these lengths fit into this one or not. Okay, so we know that if this is a right angle triangle, then hypotenuse will be the largest one, therefore 5 cm is a hypotenuse. Okay, hypotenuse. Now by this it will come you that, okay, let's assume that this is C is equal to 5 cm, and you will simply allocate it like, let's say it is A and let's say this is B. So in order for these sides to be forming a right angle triangle, they should satisfy this property, that is A square plus B square is equal to C square. They have to fulfill this property. Okay, so if you solve this, A square is what? 3 square plus 4 square. And what is C square? C square is 5 square. Okay, so this will be 9 plus 16, and this will be 25. And here it comes 25 is equal to 25. Yes, it is coming exactly equal, that is LHS is equal to RHS, that is right hand side. That is what we wanted to prove, right? Yes, Pythagoras property is being fulfilled here. That's why these sides will represent the three sides of a right angle triangle. Yes, it is true. Okay, so that's the importance of Pythagoras property. Let's solve some problems based on Pythagoras property, and let's begin with this one. In all these cases, you have to find value of x here, and x here. How will you do this? Well, it's a right angle triangle having right angle at this vertex, and the opposite side to this right angle will be this hypotenuse, right? So in this case, x is hypotenuse, and according to Pythagoras property, a square plus b square is equal to c square. You have to remember this one. A square plus b square is equal to c square, where c is what? Hypotenuse. So in this case, 5 square plus 12 square is equal to x square, right? X will be at the place of c. So this 5 square is 25, this 12 square is 144, and this is what? X square. Now if you solve this, this will be 169 is equal to x square. This 169 is exactly what? It's 13 times 30 is equal to x square. So if you solve this one, this is 13 square is equal to x square. It gives you x is equal to 30, right? Now in this case, this is right angle triangle. The opposite side is to this right angle is this one. This is hypotenuse therefore. So hypotenuse here is x. Again, a square plus b square is equal to c square. C will be again x here. So let's do it. This is 6 square plus 8 square is equal to x square, because this is a right angle triangle. This is Pythagoras property. And if you solve this, this is 36 plus 64. This is x square. This is 36 plus 64 is 100, and this is x square. This will be 10 times 10 is equal to x square, and this will be 10 square is equal to x square. Therefore you'll get x as 10, right? Now here, in this case, this is right angle triangle, and right angle here, opposite side is this one. Again, hypotenuse is x. If you solve for this one, it will be 8 square plus 15 square is equal to x square. And if you solve this one, this will be 64, and this will be 225 is equal to x square. Now if we solve this one, it will be 225 plus 4 is 229, and this is 289. 289 is equal to x square. This will be 17 square equals to x square, and this will give you x is equal to 17. We have got some word problems here, and it's based on Pythagoras property. A 15-meter long ladder, there's a ladder that is of length 15 meter, reached a window 12 meter high from the ground. So the window is at the height of 12 meter from the ground, and this ladder has been placed against a wall at a distance a. Placed against a wall at a distance a, and this ladder is reaching this window at 12 meter high from the ground. Find the distance of the foot of the ladder from the wall. So if we assume that this is the level of the ground, and if this is our wall, and let's say the height of the window from the ground is 12 meter, so if we assume that 12 meter comes here, and then you have a ladder of 15 meter that has been placed against this wall, and that's reaching here, and against a wall at a distance a. So what basically it's trying to tell is that if this is your ladder, okay, let us stop this. So the length of this ladder is, as given here, is 15 meter, and this ladder is reaching the window is situated here at a height of 12 meter, and this distance against the wall is actually what? A. Find the distance of the foot of the ladder from the wall. Foot of the ladder from the wall, that is, you have to find out this distance A. Okay, so you can clearly see that this is the ground, this is the wall, it's making a right angle, right? And if you have to think of it, this is a ladder. Of course, you can imagine a straight line. Imagine a straight line that is passing something like this. Okay, right? So this is 15 meter. This is 12 meter. This 12 meter at a height of 12 meter. So let's write this 12 meter here. Now clearly, this is the hypotenuse because this is right angle, and the opposite side to this right angle is this one. So hypotenuse is 15 meter, and if you remember the Pythagoras property that says a square plus b square is equal to c square, where c is the hypotenuse. So in this case, if you assume that this is a we already have here, this is, let's say, b, so this a square plus this b square, that is 12 square, is equal to this 15 square, right? Okay, so if you solve this, you'll get a square plus 144 plus 225, and if you solve it further, this is a square is equal to 225 minus 144. This will give you a square as 144, then we'll go 145, and this will be 81. So if you solve this, you'll get a square as 9 square. Therefore, you'll get as a as 9 meter. Okay. Therefore, the distance of the foot of the ladder from the wall is actually what? 9 meter. In this problem, a tree is broken at a height of 5 meter from the ground, and its top touches the ground at a distance of 12 meter from the base of the tree. Find the original height of the tree. We don't know this height of this height from here to here. We don't know this one. If I assume that this is the height, then we don't know about this height. Okay, we don't know about this height. Let it be h. We don't know about this, and it is broken at a height of 5 meter. Let's say that it's broken somewhere from height of 5 meter from the ground, and its then top touches the ground at a distance of 12 meter. So something like this happens. It gets broken from here. It gets broken from here, right? From here, it gets broken from this point. It gets broken, and then this top portion falls. So this has been given to us as, has been given to us as 5 meter, right? This height, and its top touches the ground at a distance of 12 meter. So this distance has been given to us as from here to here has been given to us as 12 meter, right? Find the original height of the tree. Now you have to find the height of the tree. That's really very interesting question. So you can clearly see that even in this case, you can apply the Pythagoras property because it is making a right angle. How? Let me show you. You can imagine this one as some, let me take some different color. Okay, this one. So what basically is happening is you can imagine a right angle triangle here. Let it be something like this, or straight line. Okay. So this is the base of the ground. Then goes something like this. Okay, and something like this. So this is 5 meter, this is 12 meter, this is 12 meter. You have to find this height of this tree. So let's do it. We have this 5 meter, we have this 12 meter, right? So what we can find from this triangle is, we can find this one. Let's suppose this is what is C. Let's assume that this is C. Now, you know from Pythagoras property that says a square plus b square is equal to c square in any right angle triangle. Of course, this is at right angle. This will be therefore hypotenuse of this triangle. So a square, let's say that this is A and let's say that this is B. So a square means what? 5 square plus b square means what? 12 square, and this, let it be a c square. If you solve this one, you'll get 25 plus 144 and plus is equal to c square. And if you solve this, you'll get 169 is equal to c square. If you further solve it, you'll get as 13 square is equal to c square. That means c is equal to 13 meter. So this height you got as 13 meter. Now if you would be thinking that we have to find this height h, then how is it going to help us? So can you see here that you have actually found the height of this broken part, right? You have found the height of this broken part, and sorry, the length of this broken part. So this length, that is 13 meter, and this length, that is 5 meter. So if you straighten it up, it means that 5 plus 13. 5 plus 13 means what? 18. 5 plus 13 means what? 18. It means that if this tree is straightened up again, then this will be the height. That is, h will be 18 meter.